Hey everybody, how you doing today? Happy Wednesday. Hopefully you're watching this on Wednesday night and you are going to explore with me how to write an equation when given a graph. Friendly reminder, this comes from our form equations, y equals a times a sine or cosine of b times x minus c plus d. You have in your notes from previous lessons what A, B, C, and D are. And when I look at a graph, first of all, this is really important with these problems, is because of the periodic nature, there are literally an infinite number of correct answers for every single one of these problems. An infinite amount of correct answers. You only need to come up with one correct answer. I'm going to tear this problem apart and I'm going to show you like 3 or 4 different acceptable answers. But your answer depends on what you consider your start point to be, horizontal translation. This gives you the A portion of the graph. Then the second thing I do is I figure out what the B is of the equation using the period length. Then I figure out where the axis is. That gives me my vertical translation. That's essentially D. And then once I know what the axis is, I can then count up and count down, and that'll give me my amplitude, which is A. And wait a minute, if I did A twice, that means Elliot screwed up. The start, the horizontal translation, what was Elliot saying? That's the C right here. That tells us what the horizontal translation is. Now, when you do these problems, you first have to decide, do I want to do a sine graph or do I want to do a cosine graph? If the instructions tell you you must do a sine graph or you must do a cosine graph, then you must do whichever graph they tell you to. I tend to be a little bit more freestyle on these because sine and cosine is so similar. So I'm going to do this both ways. Sine, if you think about a period of sine, sine starts by going up and then concludes by going down. So if I'm going to be doing a sine graph, I would want my start point to be here, 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 or here, or even here. These are all points that the graph is here, heading on its way up. So I could pick any one of them. We usually pick the one that's closest to 0. So I'm going to pick this. So I guess I need to add to this list. Before you decide, before you can even run through this, you need to decide whether you're doing sine or cosine. So I've decided, you know what, give me a sec. Give it 1 second here. I just want to get some different paper so I can do this same problem many times. Okay, so for this graph, P1, sine or cosine? I'm gonna make this. How can you read it all? Just zoom out a little bit. I said zoom out. Okay. Decide if you're going to do sine or cosine. Based off of what I was saying a minute ago, I'm going to do a sine graph. Then 1. Where does my graph start? If I'm going to usually start as close to 0 as possible. Let's get out my back picture. Yeah, there you go. So I could start at any one of these red circles I picked. I'm going to start here at 0, so C equals 0. Second thing I did, period length. Well, if it started here at 0, it ended at 180 after it went up, and it went down and back up again. So use this equation, 180 equals, we're in degrees, so we use 360 over b. You should also put 2 pi over b if you're in radians. So 360 divided by b, and then you solve this equation. B ends up being 2. All right, step 3. The axis, nice. In this particular case, the axis is at 0, so D is equal to 0. Then 4, amplitude, how far up did it go from 0? It went up to +3, down to -3. That means that the amplitude's 3. Amplitude's always positive. So A is equal to 3. And I chose sine, so my final answer is y equals 3 sine. Here comes the B part, so 2. The C is 0, so it's x minus 0, so I'm just going to write x. And then plus the horizontal or the vertical translation, there was none, so this is it. And that's because I chose a sine graph. Suppose, I'm going to do this in red, suppose I don't like starting my graphs at 0. I like starting my graphs the first positive value. So let's say you wanted to start at 180 degrees. Well then, that's your horizontal translation that's affecting. So now C would be 180 degrees. It's not going to affect the period length, so B would still be 2. That's not going to affect the D. That's still 0. That's not going to affect the A. That's still 3. So your equation would then be y equals 3 sine of 2 parentheses, and then the horizontal shift of 180 degrees. So x minus 180 degrees, close, close. And there was no vertical translation. So you got another equation. Now, if you don't believe these two equations are the same, go to your graphing calculator, graph this equation, graph that equation. They'll be absolutely identical. If you don't know how to use your graphing calculator, go to Desmos, try it out with Desmos. It will also work. Now wait, what if you don't like doing sine? What if you're like, I demand to do a cosine graph? Well, let's do this problem using cosine then. I'm just going to fold this over. So, P1, sine or cosine? I choose cosine. 1, if I'm going to do cosine, where would the start point be? Well, you're going to have to make an assumption here. If this is 0 degrees, that's 90 degrees. What's halfway between 0 and 90 degrees? 45 degrees. So I could have 45 degrees be my start point. Halfway between 180 and 270 degrees, I believe that's 215. That could be a start point. This could be a start point. That could be a start point. I could have the start point be like, 20 periods to the, which way am I pointing right now? For you, yeah, left. To the left or to the right. But I'm going to pick the one closest to 0, so it looks to me like it went right 45 degrees. So C equals 45 degrees, the horizontal translation. Then part 2, the period length. Well, that really, period length is never going to change on these problems, but I'm still going to do the work. If this is 45 degrees, then this one, as we figured out a little bit ago, would be 225 degrees. And if you do 225 degrees minus 45 degrees, you get 180 degrees. So 180 degrees equals 360 degrees divided by B. B is still 2. Step 3, the axis, it's still at 0, so D is still 0. 4, the amplitude, that has not changed, it's still 3. So start point can change, but your period, your B value, your D value, and your A value, that'll never change amongst your equations. So my equation, y equals, I chose, amplitude, 3. So 3 times cosine of 2, parentheses, x minus 45 degrees. Don't forget the degrees. D is equal to 0, so I don't need to put a plus 0. And that's that equation. And that's a cosine graph. So, once again, I've done this problem 3 times. It's taken me 10 minutes. But if you were to graph all 3 of these equations using Desmos or any other graphing utility, all 3 graphs would be absolutely identical because they have the same amplitude, the same period, and you can have different start points, but because they're periodic functions, they'll still line up on top of each other. All right. I have 2 more examples. I'm going to pick up the pace a little bit for the next two examples, but if you're feeling okay with this, you might want to fast forward to part 2, graphing with the restricted domain. All right, let's see. I want to have this list visible so you guys can continue to see it. All right, hey, if you got a phone with you or a screenshot or something, take a quick screenshot of this. And then you can put it on the side. Elliot has an idea. Give him 1 minute. Do 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 manana do 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 manana do 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 manana do 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 do. Check it out. There it is. Okay, move on to the second problem now. I gotta make this a little bit smaller so people can see the graph. Let me zoom out a little bit. Okay, sorry about that. Sorry about the delay. A little of this professional stuff. Okay, now, number 2 here. You first got to decide if you want to do sine or a cosine graph. You could do either one. If this is the axis, if I'm doing sine, I could start here or here. If I'm doing cosine, I could start here or here. I don't know why. I've always been preferential to cosine. So I'm going to do a cosine graph, and I'm going to have my graph start right there. So P1, Elliot decided he was going to do a cosine graph. Because of that, on my start point, I have decided my start point to be negative pi over 2. So that's going to be my C. Then the period length, well, it went from negative pi over 2 to 3 pi over 2. 3 pi over 2 minus negative pi over 2 to figure out the distance from one to the other. That ends up being 4 pi over 2, which is equal to 2 pi. So the period length is 2 pi, so 2 pi equals 2 pi divided by b. Well, that's only going to be true if b is equal to 1. So b is equal to 1. Step 3, the axis. It appears that this axis is down here at negative 1, where I put that red dotted line in. So the d, the axis, is equal to negative 1. And then number 4, the amplitude, it goes from negative 1 up to positive 1. So that's just a normal amplitude. So the amplitude is equal to 1. Put it all together. Y equals amplitude 1 times cosine of, the b was 1, so 1, parentheses, c was negative pi over 2, so x plus pi over 2, close, close, and then plus, d, so minus 1 for the vertical shift. Now, do you need all of those ones in there? No, and you really shouldn't. This one and that one, the ones that you have for multiplying, those really have no business being in the answer. Am I going to mark you down wrong for it? No, it's not wrong. It's just bad form. All right, there's a cosine graph for number 2. All right, number 3. Because I did a cosine graph for number 2, for my last example today, number 3, I'm going to do a sine graph. All right, ooh, lots of periods in this particular graph. So I've decided on a sine graph. It really doesn't matter whether you choose sine or cosine. And if I'm going to do a sine, I could do a start point here, 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 or here. And when I look at my x-axis, the only one that I have clear values for are this one and this one. So I need to start my start point either at negative pi over 2 or 3 pi over 2 if I'm going to do a sine graph. If I'm going to do a cosine graph, I'd probably just start here at pi. Negative pi over 2 is a little closer to the x-axis, or the y-axis, excuse me. So I'm going to choose C to be negative pi over 2 for that horizontal shift there. Alright, now, I got to figure out the period length. For this one, it's a little tricky based off the numbers that aren't really given to me on the graph. So, because I just need the length of one period. Well, this is what I'm going to do. I know negative pi over 2 is a start point, and I know 3 pi over 2 is. So I'm going to find this distance. 3 pi over 2 minus negative pi over 2 to figure out the distance. That's 4 pi over 2, which is, of course, 2 pi. Now, that 2 pi is split up over 1, 2, 3 periods. So if I take that total of 2 pi and divide it up amongst 3 periods, each period is 2 pi over 3. So 2 pi over 3 equals 2 pi over b, which, oh man, sorry about that. That means the only way this equation would work is if b is equal to 3. Tricky. If you have questions on that, please let me know. Next, the axis is at 2, so I know that d is equal to 2. Looking at the graph, it looks like it just goes up 1 and down 1. So number 4, the amplitude is equal to 1. And I'm doing a sine graph. Let's get into the equation. Y equals amplitude times the function sine of b times x. It's negative pi over 2, so plus pi over 2, close, close, plus the vertical translation of 2. And then, would I include all this in my final answer? No, I wouldn't include the 1. My final answer would be sine of 3 parentheses x plus pi over 2, close, close, plus 2. All right, and that is graphing or writing equations of graphs. On a quiz or a test, I'm not going to force you to do a sine graph or a cosine graph. You need to decide on your own which ones you're going to do. Other math teachers do force you to do a sine or a cosine, and I don't think that's necessarily a bad thing. It's just not what I do. All right, second thing I want to do today, and just let me eliminate this real quick. Okay. So we're going to be doing some graphing sine and cosine, but this time with the restricted domain. This one's a little trickier. You gotta use some common sense. Where's the start? The horizontal translation. In this case, the horizontal translation's at 90 degrees. The period length is equal to, this is degrees, so 360 degrees divided by 2 is 180 degrees. So my domain is 0 to 1350. So I'm going to use this starting point and period length and get an x-axis completely marked up. You might want to be using graph paper on these. If you're not going to use graph paper, you might want to use a ruler to make sure everything gets split out nice and evenly. So start point of 90 degrees, but I really need to start at 0. So I'm going to have each period be an inch, I guess. So if I went an inch, that means in this direction, because I need to capture 0 in my domain, that would be at negative 90 degrees, would be one period. And if I kept going 180 degrees, this would be 270 degrees, 450 degrees, 630 degrees, 810 degrees, 990 degrees. Oh no, I'm going to run out of space. 990 plus, Elliot's going to cheat. He's going to use a calculator. 990 plus 180, that's 1170 degrees. And then if I added another 180 to that, I get exactly 1350. So I've kind of run out of space, but I'm just going to pretend like this last one is an inch right there, and I'm going to have that be the 1350 degrees. So this is an example of a graph that you're doing a lot of periods, and each period starts and ends on this 90 degrees. The details of having all those key points in between, they're a little less important when you're doing tons of different periods. So on this particular problem, I'm not going to ask you to do 5 points in between all of these. That would end up being like 40 points. That's unnecessary. But my y-axis, I personally like to put my y-axis where 0 is, and I'm going to do that little squiggly thing to show that it doesn't start there. I'm going to put in my axis at 5, and hey, I'm using a straight edge, so why don't I just continue to use that straight edge? This is my axis. It's at 5, up a distance of 3, up to 8, down a distance of 3, down to 2. And each period started at 90, and the period length was 180 degrees, and it's a cosine. So at 90 degrees, it's at the top, and it's at the top here, which means it's at the top here, 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 and even at the end, it would still be up at the top. Their midpoints would be at the bottom. So the midpoint of this would be here, midpoint of this would be here, midpoint of this would be here, 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 and there. And then their midpoints would all be on the axis. So I'm still putting 5 dots in for every period. I'm just not asking you to have every single point on this x-axis labeled so that you're not killing yourself. Oops, and then let's see. It appears that, so from negative, I have to do one from 0 or negative 90 to negative 92. So there, which would mean the midpoint, which would be at 0, would be at a bottom point. So 0 is a bottom point. So here I go. Connect the dots. Connect the dots. La 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 la. 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 Connect the dots. Woo! What a graph!
What a graph.
What a graph. All right. So that was a restricted domain. You want to get in on in here?
Yeah.
You want to do the next graph? Come on over. All right, everybody. We have a guest appearance by Kushi.
Woo!
I need her parents' permission before she can do this one. All right, you ready?
Yeah, I'm ready.
All right, here you go.
Oh God.
Uh-huh. Be careful. You don't want to say, religious things on YouTube.
Sorry.
It's okay. You want to grab a seat?
Okay.
Take your backpack off. All right, grab a seat. Now here, let's look at this previous example here. We were so with the restricted domain, we still want to think about what our start point is. So using that equation, what would be our start point?
Negative pi.
Negative pi. So let's go ahead and get that written in, just to show a little bit of work. And then what about the period? What would be the period for this one?
Period is 360 divided by 1/3.
I noticed we are in radians.
So 2 pi over 1/3.
All right, so let's go ahead and write that down. And what's that work out to be?
6 pi.
6 pi. Okay, now, so I notice that our start point isn't anywhere near in our domain. So let's do a little side work just right over here.
Okay.
And let's just make like a fake x-axis real quick. So let's just make a fake x-axis. This isn't where our graph is going to go, but if we started at negative pi, and we went up 6 pi, where would we be at?
Over here, 6 pi. 6 pi over here.
Well, no, but if we started at negative pi, but we added 6 pi for the
Then we'd
period.
be at 5 pi.
Yeah, then we'd be at 5 pi. Is that within our domain?
It is. Well,
Everybody,
it's
I'm
not.
trying to make a video. Can you not talk, please?
It's not.
It's not in our domain, so we got to do it again.
So then we add another 6 pi.
Another.
11 pi.
Yeah. So based off what our x-axis here in our domain, how much where? I think we can go ahead and build our real x-axis. And our real x-axis is going to go from 8 pi to 11 pi. But if we have an entire period from 5 pi to 11 pi, how much of a period is actually going to go into that graph?
Well, only about half of it.
About or exactly?
Exactly half of it.
Exactly half of it. Okay, so so let's see. What would be the best way to do this? Let's just do a little mock graph here. We know that sorry, I'm pointing at the screen, but not here. If we know that a period starts here and ends here, what would the graph look like from 5 pi to 11 pi? Just a quick little sketch. Keep in mind it's a sine graph.
Then, well, you would start on the line, and then, well, up, down.
But we only need, but it's only one period from 5 pi to 11 pi. You did 2 periods there.
Oh.
Okay, and then where's the 8 pi fit into that picture?
Right there.
Right there. Okay, so do you have an idea what this graph's going to look like then? Yeah. Okay, now don't forget about our, so the next thing we got to worry about is our axis. So where's the axis go?
Oh.
-4.
-4, so.
Alright, so where are you putting your axis at?
-4.
-4, so we put the axis at -4. Alright, now what about amplitude?
The amplitude is 1/3.
Amplitude.
Oh, amplitude is 4.
4! So it looked like you set up for an amplitude of 1.
Okay, well, 0.
Okay, so we're gonna go. So with let's zoom out a little bit. So with our we have our horizontal shift of -4 and our amplitude of 4. So it's gonna go up to 0 and down to 8. And you already know based off this little scratch work of how much of it's gonna be. So what's your final graph gonna look like? All right, now, okay, so now let's zoom in just on our final graph. Now, when you think about key points, do we have all the key points we need? Yeah, let's add in 1 for that middle. All right, and then 8 pi and 11 pi, so where would that one be at?
Well, there's points right there.
I know, but if we had 8 pi and we have the 11 pi, what would be the x-coordinate for that one?
That would be at 9.5 pi.
9.5 pi! So we put that up on our x-axis. And we have a graph that has a partial domain. Everybody get up for Kushi doing a guest appearance on our math videos. All right, everybody. Thank you very much. You did an awesome job. If you have any questions, let me know. Talk to you later. Bye-bye.